Now let's continue with the mass balance introduction. We already seen why do we need to study and where do we have the source, the book. I show you that you can get the problems description in my website. If you need some help, go there. Now let's see an overview of what are we going to see in general. The first chapter we're going to see is divided in two sections, section 1 and section 2. Section 1 in general is super important for the theory. If you don't understand what's a system, what's a process, what the hell is a unit operation, streams, flows, state variables, setpoint variables, flow diagrams, etc., you will not understand how to actually do a mass balance. Now, once you have the good theory, you know what is a system and continuous flow, continuous process, transient, etc., we can continue and go to section 2, which is mass balance basics, which I will say is the most important part of the course. And let's see, we will have mass balance with one unit. Let's see, there's one inlet, they go inside and they go outside. Then we have with two or more, so this gets a little bit complicated because you can see how the streams actually start like multiplying and complexity increases. Now, we either do this mass balance with a reaction or with no reaction. Because when there's a reaction, the problem is that we are producing new stuff. Like if we have A, which decomposes in B and C, we will have to do mass balances of these guys. So take care. You need always to check how to do it with and without reaction. We will see this also in the course, don't worry. Now, mass balance in combustion will be, like, technically this is a mass balance with reaction, but what we are going to do is a special thing. We're going to check out the combustion and we'll attack it with another focus, another methodology. So it's easier to you to solve the problem. You can do it like this, no problem. But I think the mass balance combustion methodology here will be easier. And finally, also this is super theoretic, but also this is bypass. Recycle is when you get something back to the process, and purchase when you actually you are producing too much of something and you need to dispose of it. Now, this is theory, but most importantly, it's problems and exercise. You know that these two are the best stuff to understand a topic. Now, let's go to the next chapter, will be single phase. We have also two sections, that's good. Section number 1, it's our theory, what's a phase, blah, 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 blah. We're going to see in general that liquids and solids, it's okay, don't worry. We can use the mass balance we've seen before. The problem starts when we get to section 2 and we start talking about gases, another phase. So we're going to see that pressure, temperature, volume change the attitude of the gases, they change the way they work. So if you increase pressure, you maybe need to decrease temperature or etc. There are relationships. We're going to see that later. Ideal gas, sorry about that. Real gases, we will see some equations, real gases are gases that cannot be modeled with the ideal gas. And finally, we see the C compressibility factor, which is the very common form to attack a real gas problem. And finally, I'm not showing this just for theory, we're going to do mass balances with gases. That's about this chapter. Now, the next chapter is multi-phase. Last one was single phase, this is multi. Multi means obviously more than one. We have these three sections. Section 1 is single phase theory, vapor pressure and Gibbs phase rule. This is, I would like to call it theory. Just get to use some stuff like vapor pressures, Gibbs rules, etc. Now, This here is about mass balance. We're going to see a little bit theory about, like, for example, gas-liquid systems. There's only one that condenses. For example, if we have air and water, normally water either evaporates in air or condenses. That's why your car in the morning has, like, normally a little bit drops, because when you cool down air, water condenses. So this is what I mean for one condensable. Evaporation, drying, humidity processes. We're going to do mass balances. Now we go for the gas-liquid system for multi-condensables, which imagine water and alcohol. I don't know if you know it, but water and alcohol you can boil them. They will, like, increase the concentration of X and Y, etc. You boil them, you can actually you have this. You will have water and alcohol in the gas, and you will have water and alcohol in the liquid. Whereas here we only had water, not air, and in air we had air plus water. But here we have water and alcohol, and water and alcohol in both phases. We're going to use these rules: Raoult law, Henry law. Now we're going to start getting what's a dew point, a bubble point. You don't need to know that, but just get used to, like, dew point is when you get the first drop of water. The previous example I showed you about the car and the water. When you get the first drop of water, that's the temperature, the dew temperature. The bubble is, like, backwards. When you have a pot, imagine you're going to cook a pasta. You boil it, and then comes the first boiling bubble. This is the bubble point. Now, finally, we will see T, X, Y diagrams, which in general it's only composition versus temperature. And that's what we are going to see about gas liquids. In section 3, we're going to see solids and liquids, which mainly is solubility, if we put a solid in a liquid, and colligative properties, which you should have seen before in chemistry classes. Now, the transient state is the last section. I told you before it's only 10% of the course, but it's important to understand it. First, I dropped this into 2 sections. Section 1 is about theory, just what is accumulation, when to apply, cases and examples. And section 2 is about exercise, how to do the integral balance, how to solve the mass balance, and normally you use a computer to solve this. So don't worry, you're going to be able to do your transient state problem relaxed.